Hello, welcome everyone. In this lecture, we are going to study the gate model questions on Thevenin's and Norton's theorem. What are type 1 conditions or type 1 problems in Thevenin's and Norton theorem? In type 1 problems, the circuit only contains ideal independent sources and passive elements. Okay, there will not be any dependent sources present in the network. So in this linear network, which contains only independent sources and passive elements, how to calculate Thevenin's voltage? And we are Thevenizing the circuit across the terminals A and B. Then if you measure the open circuit voltage across the terminals, this will be equal to Thevenin's voltage. Then if you short circuit the terminals AB and measure current flowing through the short circuit, this current is Norton's current. So by open circuiting the terminals and by measuring the open circuit voltage, we get the Thevenin's voltage. By measuring the short circuit current, we get the Norton's current. Now to calculate the Thevenin's impedance or Norton's impedance, we have to calculate Z equivalent across these two terminals. This will be equal to ZTH R. So while calculating the Thevenin's impedance or Norton's impedance, all the independent sources present in the linear network must be nullified. That is, what is the meaning of this nullified? That is, voltage sources must be short circuited. Current sources must be open circuited. Here he is asking you to calculate the Thevenin's voltage across the terminals AB. So what is the Thevenin's voltage? It is the open circuit voltage across the terminals AB. To compute this, again I am taking help of the nodal analysis. Again, if you take this as a reference node, and this is a node whose voltage we are interested in, let this voltage is nothing but VOC, because this point is same as voltage of this complete point is VOC, which is nothing but our Thevenin's voltage. So I am writing this voltage of this node as VOC. Like KCL, assuming all currents are leaving. Now if you apply KCL, assuming all currents are leaving, and since it is open circuit, the current through this branch will be 0 ampere, since the terminal A and B is open circuit. Now let us assign this I1, I2 and I3. By the KCL we have I1 plus I2 plus I3 is equals to 0. What is the value of I1? Nothing but VOC minus 12 divided by 3 plus I2 is equals to, in the opposite direction 1 ampere current is flowing, so minus 1 plus I3 is equals to, this total I3 current will flow through the 6 ohm resistor, so this will become VOC divided by 6, that is equals to 0. So from this you are going to get, if you take VOC common, 1 by 3 plus 1 by 6 is equals to 5. So this VOC into 1 by 2, that is equals to 5, which implies VOC is equals to 10 volts. So this is your Thevenin's voltage across the terminals AB. In this question, he is asking you to compute the Thevenin's voltage across the terminals A and B. So, here you can carefully observe, it's a very simple question. So, what is let this be the reference node whose voltage is 0. Now, the voltage at this point is how much? 100 at an angle 0. Okay. Voltage at this point is also 100 at an angle 0. Voltage at this point is also 100 at an angle 0. So, this voltage that is present at this point is getting divided across the two series impedances. So, voltage is getting divided across the two series connected impedances, and your Thevenin's voltage is the voltage across the 4 ohm inductor. This is your Thevenin's voltage. So how to calculate this one? We can simply, what is the voltage at this point? 100 at an angle 0. So your Thevenin's will become, the voltage at this point is 100 at an angle 0. So total voltage is 100 at an angle 0. We are simply applying the voltage division rule, and the impedance where we are interested in finding voltage is J4 ohm divided by 3 plus J4. So this is the Thevenin's voltage. To bring it to our form, it's very simple. Multiplying with the complex conjugate into J4. What is the complex conjugate of 3 plus J4? 3 minus J4. So divided by 3 plus J4 into 3 minus J4. So this will become what? VTH will become 100 into J4 into 3 minus J4. This value will become how much? 25. So 1, 4. So this will become, your VTH will become J16 into 3 minus J4 volt. So he is simply testing whether you know the voltage division rule or not in this example. So option A is the right option.